Hello, and welcome to some inference for regression examples. These are the basic exercises. So there's going to be some very simple ideas we're going to cover today. And let's go ahead and get started. So this first example has some data that I've taken the liberty of typing in Minitab 17. And the first thing we're going to do is make some scatter plots for this data and decide whether or not it satisfies the conditions we need in order to do a linear regression. So to create a scatter plot, we're just going to go up to Graph, Scatter Plot. And we're going to use the simple command because, well, we don't need anything complicated. All right, and then it asks us for our x variable and our y variable. I'm going to put my y in here and my x. You'll notice that it gives you the option to add in lots of these. So if you want to do a bunch of graphs at once, you can, but we're just going to do this first one to start off. There's also a bunch of options on things you might want to do, like multiple graphs or changing your scale or doing some things with your data or labeling it. I'm not going to do any of that. I just want a simple scatter plot to see what the shape of this looks like to decide, well, not just the shape, but to decide if there's an association. Come on. There we go. Okay, so the first thing we want to do is we want to go through our steps for describing this. So overall, since it starts in the top left and moves to the lower right, this looks very much like it has a negative association to it. So, oh, sorry, not negative association, negative direction, which is a part of association. Oh, come on. Okay, next we want to look at, does it appear to be linear? It looks pretty linear to me. As far as shape goes, it looks like a fairly strong relationship. It's kind of hard since I don't have as much data here to judge the scatter, but I'm going to call this a strong. And it doesn't appear like we have any outliers, so this is looking pretty good as a candidate for performing linear regression. Okay, so the next thing is this note that it has that the best fitting line for these data has the following intercept and slope. Use the estimated equation to predict the y for all 6 values of x. Now, I'm going to do this kind of the cheap and lazy way to come up with the list of predicted values. So I'm going to shrink this. I'm actually going to move this over. I should have thought of this ahead of time. Regrets. Okay, there we go. So I want to create my predicteds. Minitab calls this fits. More often than not, when you're doing linear regression, you can make Minitab produce the fits for you and then get the estimated residuals for you. But if you wanted to do it using the equation that they have, you want to round like they do. So I'm going to at first use this information to do it. And then for my second time going through this problem, I'm going to go ahead and do it automatically. So fits and residuals. All right. So to create the fits value, I'm going to be using the calculator menu. That's how you can create stuff from data. So I want to restore my results in fits. And the expression I want to use is I want to use linear regression. So I want the slope 18.9 plus my, where's my slope? Oh, sorry, intercept plus slope. My slope's negative. I shouldn't have done plus. I should be doing minus. Sorry about that. 0.260 times, and now I want to use the variable for the x values. So x1, I want to put that in there. And then I'm going to hit OK. And there's the values you would get for the fit. So you should be listing that here for part B. 9.8, comma 8.5, comma 5.9, comma 2.0, comma 8.5. Why am I reading these out loud? 11.1. Okay. So there they are. Woohoo. Least interesting thing we've done in a while. Check. All right, now we need to find the residuals. So one of the things you hopefully remember about the residuals, it's the actual value from the data, which would be y1, minus the predicted values, which were the values I just found. So I want to make the residual column calculate that. So we're going to go up to calculator. And so here, I want to change this. I don't want to store this in fits. I want to store it in residuals. Okay, and I want to change my equation. So I'm going to do actual values minus predicted. So I got to do y1 and then minus the fits, and that will give me my errors. So my residuals, let's see, I am off by minus 0.8, minus 0.5, minus 1.9, comma, 1.0, 1.5, and then 0.9. I should have done these zeros on these guys too. Okay. And now you're asked to calculate the residual standard deviation. Hold on a second. Oh, what is it doing? Okay. So just in case you forgot, let me make a little bit of space here. The formula for SE is the square root of the sum of the errors, residuals squared, divided by n minus 2. So what I'm going to have to do here is take all these residuals and square them. So negative 0.8 squared plus negative 0.5 squared, and so on and so forth. So I got to get through all of them. And then add 0.9 squared, and then divide by my sample size minus 2. And since this has 1, 2, 3, 4, 5, 6 things, I'm going to have to calculate that. So let me pause this while I pull up my calculator to do this with. Or you know what? Let's make Minitab do it. Okay, so we'll do Resi2 as residuals squared. So I'll just make it do all the squaring for me, because that will be better. So there's a couple different ways you could do this. Minitab will let you square. No, I want to do residual 2 there. You can multiply residual by itself, or you can make it do a power by doing star star square. I always forget what it is exactly that makes you square. I did it recently, so I remembered, but you know, just multiply it by itself if you don't. So let's go ahead and hit OK. And that'll produce the squares for me. And then we can add these all up and then divide by, sorry, this should be 6 minus 2. Come on. Why does this never work? So we're actually going to end up dividing by 4. Okay. No! I'm hitting all kinds of buttons. Good times. Stop drawing. There we go. Okay. So, grab my calculator. Okay, so this will then be equal to, come on, the square root of 8.56 divided by 4, which is the same as doing the square root of 2.14, which that square root comes out to be about, 1.46, just so you know. I'm rounding a little bit there, probably more than I need to. You should double check this calculation to make sure you get the same thing I did. So if you've been watching this and thinking, ooh, there must be an easier way to do this. Yes, there absolutely is. Okay, so I hate to say it, but ignore C3 through C5 here. We're not going to use those. But I am going to make Minitab do this for me. So if we go up to Stat, Regression, and then Fitted Line Plot, tell it that I want y1 as my response and my predictor to be x1, and tell it we want a linear model that's going to produce the line for us. It might not round as much as we did here or round differently, but it should produce close to the expected values you see here with fits and resi and all that. So now I'm going to hit the storage key. Woohoo! And then what I want is I want the residuals and I want the fits. Remember, fits are predicted values. That's Minitab's words for predictions. And then residuals is, well, the residuals. Let's go ahead and hit OK. And then I hit OK again. It's going to produce a bunch of stuff for me. Oh, look, there's a graph. Woohoo! So there's a line. Yay. It's pretty good. So, I mean, like, our squared's looking pretty good. And then it should have stored these somewhere. It's probably at the, oh, sorry. They usually throws them at the end of the document, so it might be all the way. Yep, there they are. So it stored them over here, but you can see that these aren't nearly as rounded as the values that we got from using their equational line, so just be a little bit careful with that. The other thing is, if you scroll up and look at the output, it gives you the value of S, and that will be a good approximation to what you should be getting even if you use their values regardless. Another thing you can notice about this, I'm going to scroll up a little bit higher, is this is the equation that Minitab was using, and it is a little bit different than the one that was given to us in this problem. So just keep that in mind, rounding and whatnot. So if they give you a specific value, you might want to do it using the method you saw me do first, rather than doing the regression line. Okay, if you remember, that is the value that we were calling in the notes. So in order to do that, I'm going to use its formula. Come on, draw. So that formula, in case you forgot, is the standard error of the slope. Remember, slope is b1. So that's going to be the error of the residual, or standard deviation of the residual, the standard deviation of x, times the square root of n minus 1. So we already have the standard error from up above, the 1.46. We know the sample size is 6. So this is going to be the square root of 5. And then the last thing I need is the standard deviation of x, which I have nowhere. I'm going to have to calculate that real quick. So let's go on up to stats, basic statistics, and then display descriptive statistics. And then I'm going to throw x1 in here, and then I'm going to hit the statistics key. The only thing I really need is the standard deviation, so I'm going to unselect everybody else. Good. Let's go ahead and hit OK, and then hit OK again, and that will produce the standard deviation we need for this last part. And evidently, it's totally not going to fit. 12.52. Oh no, this looks like gibberish. Okay. Come on, pen, save me. Okay. And I'm just going to pull out my calculator to do that one real quick. So and if you do that, you get about 0.0521. Woohoo! So there you go. That's how you do that one. Fun times. All right. The next thing up is we're going to calculate the t-statistic. So I got to do my slope. Come on. Oh, it still wants to draw. Sorry. Oh, I got to take my slope, in case you forgot what t is. T is going to be my slope value, b1 minus whatever I thought beta 0 was going to be, divided by the standard error of my slope, which I just found. So that's going to be, well, my slope was negative 0.260. I'm assuming it's 0 based on the null hypothesis, divided by, oh, I need that number from up above. So 0.05215. So I'm going to calculate that. And that comes out to be negative 4.98 roughly. Oh, my point didn't come up. So as you look at this, we want to next calculate what our p-value is going to be. And in order to do that, I need my degrees of freedom. So remember, the degrees of freedom for this we always do is n minus 2. So for us, that's 6 minus 2, or 4. And now, last but not leastly, I want to calculate my p-value, because once I have my p-value, I can finish up my hypothesis test. So I've got my test statistic, I got my value for my degrees of freedom. Sorry, I didn't write that was my degrees of freedom. It's always better to clarify. DF, down for fun. All right, and so we're going to go up to graph, probability distribution plot. Just a reminder, because I didn't say it a second time, we are calculating p-value right now. I want to do view probability. I'm going to hit OK. And I want the t. Where is it? There he is. And my degrees of freedom is a 4 in this case. And then for shaded area, I've got 2 values I want to do. Now this is a two-tailed distribution, so I want to do both tails. And I'm going to put in my value as 4.98. It'll actually take the negative or the positive for this, so we're good there. It prefers the positive because if you're looking at the picture, it's like, oh, it's right here. Even though this is a negative one, but since we want both tails, it's, you know, it's symmetric. We're going to hit OK. And there is our teeny tiny p-value, and there are 2 of them. I'm going to round this terribly and call our p-value, it's weird that it capitalized that, as being 2 times 0.004. So I would call this 0.008. Okay, so as you look at this, last question for this problem. Is the slope of the regression line significantly different from 0? Explain. Well, yeah, it totally is. And it is because my p-value is so small, so we're definitely going to be rejecting our null. Since the p-value is smaller than alpha, we will reject the null hypothesis. So we now know for sure that, hey, it appears that my slope is significant, and therefore this is going to be, you know, a significant relationship, or yes, there is an association here. So if you looked at this by hand stuff and you thought, ooh, this is getting kind of disastrous, here's another way you could do this that produces some results from Minitab that would help you. So I'm going to do some different things. I'm going to close this t-value because I don't need it anymore. No. Okay, so let's say you're like, by hand, this is looking kind of rough. I agree. Let's go back to stat regression, and then instead of doing fitted line plot, I'm going to do regression and fit regression model. We'll also see this when we go and do our case study, that sometimes this model version is better than doing the fitted line plot. So the response I'm looking to get is y1. The continuous predictor I have is x1. I'm going to once again hit the, do I really want storage? Nah. I'm not going to mess with any of these options. I'm just going to hit OK because the base version of this gives you what you need. Come on. Ooh, she's going a little slow today. Here we go. So the regression analysis you get from this menu is a little bit different. So you notice it gives you the equation last, and then it gives you a model summary and an analysis of variance up top. We don't need the analysis of variance currently. What we want is this stuff, the coefficient and model summary. So as you look at this, it gives you all the values you need to decide if your model is good in the model summary, and then it gives you a coefficient value. So if you look down through this, it gives you everything you need to do the previous values. So you notice, oh my gosh, there's my t. And, oh my gosh, there's my standard error for the coefficient. Which coefficient? The slope. Where does the slope go? Next to x1. So that coefficient. There's my slope, and there's my standard error coefficient, aka the standard error of the slope, which I have right here. So this value right there goes with this one. Yay. So if you hated calculating this by hand, there it all is in the model summary. It also gives you the correct p-value right there, which is kind of fun. So all the stuff you just saw me do by hand, you can do using the, once again, the stat regression, fit regression model key. Now, I would caution you that the fit regression model section has way more options to it, and there's lots of places where you could have crazy things happen. So be careful using it. We're going to see just some of the things you can do with it when we hit chapter 18. So, you know, things are coming down the road. All right, let me shrink this down. And we're going to go ahead and go down to number 3. Which I got to get my setup correct. Hold on a second. I definitely should cut this in post. All right, down to number 3. So number 3 has some different data, and I'm going to bring 3 down here. Okay. And I'm going to move this over and paste the data for 3 in here. There we go. All right, let's do number 3. So, hey, what's the predicted value when x is 16? So it's asking you for the y hat when x is a particular value. I don't know why it's doing this. Won't let me make my text any bigger. Whatever. All right, so let's see. Let's see. My y will be equal to, it's my 19.3, that's my intercept, minus 0.795 times the value I'm looking to predict, which is 16. I have to pause this because the way this is formatting is driving me nuts. Okay, that looks a little bit better. And so we'll just throw that into our handy dandy calculational device and come up with 6.58 as our predicted value. And then next up, we're going to develop a interval for the predicted value of the mean when x equals 16. So this is a little bit complicated given raw data, but we can definitely do this. So hold on just a second. I need to make more space to do this. Should have did this beforehand. Okay. Okay. So the formula for this, in case you forgot it, is going to be, come on. Oh, come on. So the formula, just in case you forgot it, is the predicted value for y plus or minus the t-value times the standard error, where the standard error is calculated using a bunch of complicated roots. So I don't remember where this is at in your notes exactly. Oh, I do. It's like near the end. So how are we going to do this? Well, we know the predicted value for y. We just found it. That's 6. Oh, this is terrible. This is the worst thing I've ever done. This is unacceptable. Okay, so we're using the predicted value for y, which is 6.58, plus or minus our t-value, which I'm going to find in a minute, so I'm just going to leave some parentheses there for it, times the square root of, we need the standard error of the slope squared, which we found is up above as 0.182 squared, times the predicted value that we're using, which is 16, minus the mean of x squared, which is 16.2 squared. Oh my god, this is illegible. I'm going to pause and type this out. So I'm going to type a word equation. This is going to be the worst thing ever. So our predicted value is 6.58 plus or minus a big root. It's got to be a big one. Done. Okay, so this is kind of too small. Hold on. Oh, good. It's getting cut off again. There we go. Still not enough. Okay, back to design. Okay, so now I need the standard error of the slope, which is up here. This guy, 0.182 squared. Come on. We're going to multiply that by the value that you're predicting, so that's 16, because that's the x value, minus the mean of the x's, which I calculated ahead of time to be 16.2 squared. All right, and all of that plus, ready for this? A fraction. And that's not going to fit. So I'm loving this right now. Feel my frustration. I hate word equation editor for lots of reasons. And I hate that this won't automatically adjust to fit. I have so much hate right now. Okay, so good thing I never ask you guys to type these. Oh, come on. All I want is to be in the numerator of that fraction. Go, go, go. I'm normally such a positive person. This is driving me a little crazy. How did my mouse end up over there? I don't know. Okay, the numerator of this fraction should be the standard error for the residual squared, which is 1.3, and then we got to square it. And that just screwed up everything, so I'm just going to cry alone. with me in front of this computer and no human interaction, or try to make it square it. We'll see how that goes. Haha! One thing I want all day. All right, there's our square. Okay, now I gotta get back into the bottom of that fraction somehow. No, no, we'll go right there. Okay, and then the denominator goes your sample size, which was a 5. Okay. So that's just half of this. I still don't have the t value on here, so I gotta find t. Hold on a second. So, since we're doing a 95%er, and my degrees of freedom will be a 3, I gotta figure out what this is gonna be. So, we're gonna go over to graph, probability distribution plot, view probability. My degrees of freedom is now a 3. In case you're forgetting where I'm getting that 3 from, it's because I have 5 data values here, and you subtract 2, one for the mean of x, one for the mean of y. Whew. We go over to shaded area, and I want a 95% t. So that means I want to input a probability, because that's my probability. And I want 95% in the middle, which you might be tempted to select middle here, but you don't. What you want is both tails to have 5% of area in them, so I don't have to change this. So that it's 95 in the center, and then 5% split between the two tails. Now we hit OK. And there's our t-value, 3.182. So it goes right here. I hate Word. No, all I want to be able to do is draw. Ah, okay, there, I got it to fit. We're going to accept our losses, and that's the one we're going with today. Anyway, so if you do this addition, subtraction, all of this correctly, with all of your squares correct and everything working good, what you should get for the lower end of your interval, I'm not making this any bigger because I don't want it to screw up, is 4.705, and the upper end should be 8.413. Okay, so that's how you do that one. Good times. I'm actually going to copy this because I need it, well, parts of it, to do the second one. Okay. So that's the interval for the predicted value for the mean value of y when x is 16. Now we want the prediction interval, which is like all the possible values for for y when x is 16. So it's similar to this, but not exactly. I really want to set this to, there we go. Auto is no better. I'm a liar. It doesn't make it fit. There we go. I'm going to make this just slightly smaller because otherwise this is not going to fit. Doot. Okay, so looks the same. Same t-value because we're still doing 95%. Our degrees of freedom are exactly the same. Same y hat value because that doesn't change. What does change is this stuff in the middle. So here's the first thing that changes. You do not square the mean that you're dealing with. You just use the straight x mean that you started with. You do square their difference though. So that's the part you're going to be squaring. And then we're going to tack on one little extra term at the end. So we additionally add the standard error for the residual and square it one more time. Oh boy, that did not fit at all. This is like watching terrible math kung fu, trying to make everything fit. Maybe it's Microsoft Word kung fu. Because like this is just not wanting to show up nicely. Okay, so that's what the equation looks like if it's entered in correctly. If you enter this in correctly, the value you should get should be, and I'm so glad I calculated these at a time, 2.025 comma 11.093. Okay, if these two seem like a big headache for typing, whoa, they are. I'm not looking for you to type out all your work for these, but I do suggest that you calculate these to make sure you get the same numbers that I do, plus or minus rounding. The other thing I would suggest is, I do have in the case study video how to do this on Minitab, these two intervals, and it's a lot faster. Big surprise, you know. No big deal. But don't worry about memorizing these formulas. You'll have them on your formula sheet as always. All right, last question. Woohoo! Which interval is wider? Okay, this is not a trick question. Who's wider? The lower one, because it always is, because it's covering all possible values and all of the uncertainty for one particular value of x, not just looking at the average. So, the prediction interval and it always is. Since you're not just predicting the mean. Of y when x is 16. Okay, and that's about it for these 3 examples. Hope you enjoyed it.